Greetings, Karma enthusiasts. I'm delighted to introduce a new Karma short course on data visualization. In this brief introductory video, I'd like to introduce myself and tell you a little bit about the Karma short course itself. So first about myself, my name is Goran Kuljanin. I'm an assistant professor in the Department of Management and Entrepreneurship at DePaul University, which you can see here in the background in downtown Chicago. Now, I'm the director of the Master of Science in Human Resources program in my department. In that program, I teach fundamentals of people analytics and advanced people analytics. In our Masters of Science in Business Analytics program, I also teach several courses, including a course on data visualization. Now, in both my research and consulting work, I find data visualization a critical tool for both generating insights and communicating insights about data. So as a result, I love teaching data visualization, and I look forward to having you in the Karma short course. So now I'd like to share my screen and tell you a little bit, provide a little bit of a note on why data visualization itself is important and give you a little bit of a flavor of the kinds of things that we'll cover in our course and the kinds of tools we'll use to actually develop data visuals. So I'll share my screen here and go to a PowerPoint deck. Okay, so here we go. And so first, I want you to consider the following four different data sets. They're enumerated at the top. We can see by the Roman numerals 1, 2, 3, and 4. Each data set presents data on two variables, x and y. And we have 11 observations for each data set. And then at the bottom, we see a curious thing if we're observing the calculations across the data sets, which is that the mean variance values of both x and y are exactly the same across the four data sets. And furthermore, if we look at the correlation and the regression line between y and x, we also see that they're exactly the same across the four data sets. So looking at these summary calculations that we commonly compute, we might conclude that these data sets are telling us the exact same information. They're telling us, for instance, that the relationship between the x and y is the same. Now, if we actually study the individual values of x and y across the four data sets, we see that they're not exactly the same values. We see variance across the values of x and y across the data sets. Now, given that we're computing the same correlation and the same regression line across these data sets, we might conclude, well, of course, there's going to be variance across these four data sets. They just might be different samples from an overall population that has the exact same relationship between x and y. Yet computations cannot always provide accurate insights, or complete insights, perhaps is the better way of putting it. If we were to actually plot this data, then what we would discover is that the four data sets communicate and indicate completely four different relationships between x and y. We can see in the top left, there's essentially a linear relationship between x and y with some noise around it. In the top right, there's a curvilinear relationship, a pretty clear one without any noise. In the bottom left, there's essentially a perfectly linear relationship between x and y with one outlier. And in the bottom right, it suggests that there is no relationship between x and y except for one outlier that kind of makes for a spurious relationship between x and y. So what we can see here is by simply visualizing the data, we generate insights about the nature of the relationship between x and y. And it's rather quick for us to pick up what is the nature of the relationship between x and y. And therefore, it allows us to easily communicate that relationship to ourselves and, of course, to others. So in this brief example, known as Anscombe's quartet, provides a powerful reason for why you'd want to develop your data visualization knowledge and skills. Now, a next note that I want to say, just because you can put together a visualization, it doesn't mean that each visualization is equally insightful and useful. So if we take, for example, this visual that we see here, and we study it long enough, We could see that it's data being displayed about cars being sold in various dealerships. And we can see that the relationship is being displayed over time from 2016 to 2019. And if we study the graph, we can see that perhaps certain dealerships sell more than others. But if we continue to look at it, we can see that the graph is sort of confusing and it's not exactly clear what we should be paying attention to. There's this mysterious black line running through the middle that is not labeled in the legend. We might perhaps infer that that is an average across the dealerships, but it's not totally clear. And furthermore, it's not clear that we should be paying attention to that as opposed to perhaps the individual lines from the specific dealerships. On the x-axis, if we pay attention to the labels, one, we see that they're cluttered, and two, we actually see there's this gap that happens from 2017 to 2019. So 2018 is mysteriously missing. It might be mislabeled or truly the data might be missing, but there's no break, let's say, in the lines. So from this single visualization, even though we put it together, we're not sure what should be the insights. Now, of course, we can build a single or multiple visualizations of the same data to be more clear about what the insight should be. And here we see two visuals that separate out the messages that we want to communicate from this data. So on the left-hand side now, we see the individual car dealership data being plotted just like in the original visualization. But now all the colors of the individual car dealerships are in gray, and the average line is labeled and it's a different color in black and it's sticking out in the foreground. Indeed, the text above the visualization discusses the average line. So clearly, the point of that visual is to provide the general average trend across the dealerships across time, with providing some distributional information across the car dealerships. We see the x-axis labels are now less cluttered and clearly labeled that this is actually data from 2017 to 2019. Now, on the right-hand side, if we want to actually compare dealerships, then we have a little bar chart that compares the dealerships for a specific quarter for a specific year. And there on the right side, it's also kind of makes sense to compare them on Q3 of 2019 because that's the last data point that we have on the left-hand side visual. So in this case, we've separated out our messages and we've created much clearer visualizations, and therefore we have much clearer insights. So in the Karma short course, we'll not only talk about how to build visualizations, but we'll also discuss visualization principles, such as this one, that we want to ensure that we have clear insights from our visual. Okay, so in the Karma short course, how will we go about building visuals? Well, we're going to use the powerful analytical software duet, R and RStudio. R is the analytical programming language, and RStudio is the integrated development environment that uses R to develop our visualizations and our other data work. So if you are not familiar with R and RStudio, no need to worry about that. I generally teach to students who are novices, both to analytics and to scripting programming languages such as R. And you'll be able to follow the course and pick up and work on examples that I provide, and including exercises that I provide as well. So no need to worry about that. You do not need to study beforehand or develop your skills. Of course, that is useful if you are familiar with R and RStudio, but it's not necessary. Now, as we go through the course, we'll actually be relying on R packages to develop our data visualizations. And here I'll just list some of the packages that we will rely on. We will do our work in what are known as R Markdown scripts that allow us to both write narrative text to describe what we're doing and to write code all in one place. The main plotting package that we will focus is the powerful ggplot2, but we will also introduce other plotting packages in R, such as Plotly and gganimate. I will now jump out of the PowerPoint to show you just a little bit more information that in this course, as we develop data visualizations, we'll be working with data itself. So we'll become familiar with other packages that facilitate our ability to work with data and prepare data for data visualizations. A great framework for working with data in R is known as the tidyverse framework. And the tidyverse is essentially a meta package consisting of multiple specific packages that facilitate our data analytical work. ggplot2 is one of the packages in the tidyverse, but you can see some of the other packages here, and we'll become familiar with those as well as we prepare our data to actually develop visualizations in R. I will also provide links and information and discuss information from various great and free online resources, including complete books about building visualizations in R, including with ggplot2. And so, for instance, here is the kind of a guide to ggplot2 written by the author of the package, Hadley Wickham. And this is sort of provides a more theoretical overview about the mechanics of building plots in ggplot2. We'll also discuss applied principles of data visualizations and books that you can reference when you want more information about them. And we'll also provide information for the various different packages, including here R Markdown and the analytical notebooks that you can produce with R Markdown, which we'll be producing in our course. And then we'll also review information from these other packages that I also mentioned, such as Plotly. For instance, this website here also shows you great examples of the different kinds of visualizations you can build in ggplot2 or the Plotly package as well. And here I cannot run a data visualization course without producing some sort of animations. Animations are irresistible to me. So we will definitely be using and developing animations in the Karma short course. This comes from the GG Animate package, which allows us to easily animate ggplot2 visualizations. So in brief, that is the Karma short course that I have planned. I hope to see you there. Before the course starts, I would provide instructions on how to install R in R Studio. That would be the only sort of pre-work that you would need to do, but fairly easy to install. And of course, in the meantime, you can always reach out to me beforehand to ask me any questions about the Karma short course, and I'll be delighted to answer those questions for you. So I hope to see you there and looking forward to it myself. Big cheers for me.